Somebody once said that if the only tool we have is a hammer, every problem looks like a nail. Well, in computer networks, we have a lot of different looking nails, a lot of different problems and issues that come up. And so we want to be aware of the tools and commands that we can use to either verify or troubleshoot a networking issue. So in this video, we'll take a big picture look at many of those tools and commands and also their intended purpose or how they can help us on our networks. So let's build a list together and we'll take a look at how those tools and commands could help us. For our Wi-Fi networks, it would be awesome if we had a Wi-Fi scanner. And that way we could tell if there's other access points out there and also what their center channels are and hopefully steer clear of what those other frequencies are so we can have a nice clear Wi-Fi signal. If we want to take a look at the frames and the packets and look at the three-way handshakes, to do that we'd want to use a protocol analyzer. An example of a protocol analyzer we've used a few times so far is Wireshark. If we're curious about is TCP port 80 open on this server, or is TCP port 23 open on this router? Or is TCP port 22 open on this firewall? To discover that, we could do scanning of the network, and we'd use some type of a scanning application to do that. And we could do scanning for individual IP addresses to see if they respond. We also could scan for specific ports. So the thought there, if we do a scan, or effectively a TCP SYN request to port 23 and the router responds, that implies that that port, TCP port 23, is open. If our service provider has guaranteed us 10 megabits per second of throughput to the wide area network and or the internet, it'd be great if we could measure that. So one way of measuring that over time would be a performance analyzer. If our manager came up and said, hey, can you tell me what percentage of our network traffic is via streaming services like Netflix and HBO Max and so forth, that'd be really hard to tell unless we had some tools that could extract that information for us. So a tool that can help us identify what is coursing through the veins of our networks is a tool called NetFlow, which we can run that on various devices in our enterprise, and it just can gather for us a high-level overview of the traffic it sees and then report that over to a NetFlow collector. And then with the NetFlow collector, we can take that data and then answer those types of questions like, what is the number one application that we're using? Who's chewing up most of our bandwidth? Who are the top talkers on the network? What protocols are they using? And so forth. If we're updating a networking device like a router or firewall or switch, we may need to copy software to those devices. So even though it's an insecure protocol, trivial file transfer protocol, which doesn't care much about authentication, and it doesn't care anything about encryption, that's a very popular protocol to use when we're doing firmware and other updates on a networking device. Now, if this is in our lab environment, no problem. We can put the TFTP server right next to it. However, if the only access we had to this router was over the production network, we probably would want to avoid using TFTP and choose something like SCP or something more secure. But because it's been around forever, TFTP is still often used to do updates to network infrastructure devices. And TFTP is an acronym for the Trivial File Transfer Protocol. Another very common tool is a terminal emulator. And that's software that we'd run on our PC. And then we could connect with a console port, for example, to a firewall, or we could use the terminal emulator and connect like with SSH securely over the network to an IP address on the managed device. And it's the terminal emulator that's providing that functionality for us at the computer. That's the software that's in use. Now, when we're working with computers as well, and it depends a little bit based on the operating system that they're running and what flavor of operating system they're running, but there's also a whole suite of tools that we can often run right at a computer. And I'll put those in the category of CLI, which is an acronym for Command Line Interface. So we're going to have commands that help us understand what the IP addresses are on those devices, which could range from the command ipconfig on a Windows device or ifconfig on many Linux systems, and the command IP address on others. So once again, it varies just a little bit based on the platform you're on. And if we have a user that can't get to the internet or thinks they can't get to the internet and we want to test that, one great connectivity test at the command line is ping, which is an acronym for Packet Internet Groper, believe it or not, but we just call it ping. It's basically a way to verify at layer 3 that we have connectivity between us and some other device. So let's imagine that computer 2 did a ping to 8.8.8.8. And let's also imagine that computer 2 is at 10.1.10.150. In the protocol stack, as that data gets ready to be sent on the network, so here's the application layer, and the transport, and the network, and the data link, and then we have the physical. So that's layers 1, 2, 3, and 4. So if we ping an IP address, we're effectively testing everywhere here and down. So when this computer does a ping to 8888, it says to itself, whoa, that's on a different network. So at layer 3, it's going to have this as the source address, 8888 as the destination address. And then as that is further encapsulated down at layer 2, it's going to put the layer 2 address of its default gateway as the destination. And I'll put that right here. So destination would be router 1 and let's just call that 0/0 interface, that layer 2 address. And for the source address, it'd be computer 2. So the source would be computer 2. So that data is then sent into the switch. The switch, who knows where the layer 2 addresses are, forwards that frame from this port where it came in on over to the port where the router is. The router receives it, de-encapsulates it, looks at the layer 3 destination address, and then it continues that process of forwarding it based on its routing table to the next hop in the path, who does the same thing, until eventually it hits that device at 8888. Also, somewhere along the path, either router 1 or the firewall or router 2 had to do address translation. And that's because we're using RFC 1918 addresses over here, and we're going out to the public internet. So as far as troubleshooting goes, if we wanted to see on a computer if it knew about the layer 2 address, if ARP was successful about the layer 2 address of its default gateway, there are commands related to ARP on the various platforms as well. And they're slightly different based on the platform you're at. For example, it won't be exactly the same syntax on a Windows computer as on a Linux computer. And on other devices like routers and firewalls, they also have capabilities of ping and ARP, except those commands will also be slightly different based on that platform. But the idea is that we can extract that information and see if ARP has the layer 2 information for that next hop in its cache. So let's say a ping to 8888 worked, and that would mean that computer 2 has connectivity to the internet. Then let's imagine we did a ping, but instead of pinging an IP address, we ping www. Let's go ahead and use Cisco because it's short, .com. So when we ping a name, now we're beginning to test name resolution. And if there's a problem with name resolution, where we can't resolve the name of cisco.com out to an IP address, we have some tools that can help us sort that out as well. And on Linux, there's an application called dig that we could run on our computer. And most computers have some flavor of NS, which is an acronym for name server lookup, that goes directly out to a name server and does queries. And that's a great way to verify if name resolution is working by using these tools. Another awesome tool that we can use is traceroute. So I'm going to write it out as traceroute, but on Windows it's going to be TRACERT. And the reason it's shorter is back in the day, there was a limit on the actual length of a command. So it's called TRACERT. And what that can do, that can help us identify how far in the path a packet made it. So if we did a traceroute from computer 1 or a traceRT from computer 2 out to a internet resource, it could show us the individual layer 3 hops in the path. It could show us R1, the firewall, this router, and other routers in the path up to that point. It's also helpful because it can tell us where it stops working. Now, not every network device is going to respond back with the information that's needed for traceroute, but many of them do, and that's why it's a really helpful tool to have in our arsenal regarding tools to troubleshoot a network. If we will look at the routing table on an end device, the command on Linux is route, and on Windows there's a few different ways of looking at it, including netstat -R, which is going to show us the routing table. Another awesome benefit of netstat is that it can show us open connections. So if this device has connections out to servers here in the organization and connections that are open out to servers on the internet, netstat can reveal that to us and show us that those sessions currently exist. And there's also some additional options with netstat that we can use to get more detailed information on those sessions. And on desktops, a lot of them have built into them, they have applications like SSH, which is the program that would be running to be a terminal emulator, or Telnet, which again is a terminal emulator application that'd be running on the computer. When possible, we'd want to use SSH because it's secure, and we'd want to avoid using Telnet because it's insecure. And if we want to see the details regarding what's going on between a computer and a server, and look at all the packets and get information on them, one way would be to use a protocol analyzer, as we touched on earlier, or we could use an application right at the command line of the end device to reveal what's going on with the packets. And one of those applications is called TCP dump. So if we were having a problem connecting to a server and we want to take a closer look at like the three-way handshake and the details there, TCP dump can be used on that computer to show us exactly what's happening. And regarding scanners, one of the most popular and free scanners out there that runs as an application on a computer is called NMAP. And there's a cousin to that called ZENMAP, which is basically just a graphical user interface for Nmap. So Nmap is a scanner that can do things like look for open ports, find out what devices are on the network, and using the appropriate options, it can also do interrogation of those devices and extract lots of information that the attacker or hacker would love to know. For example, if the attacker can figure out what flavor of operating system is running on this server, with that knowledge, the attacker could then take a look at that platform and that operating system to look for any known bugs or known vulnerabilities. And if those exist, the attacker could then proceed to exploit those vulnerabilities. So when working with the network, it'd be important to be, first of all, aware of the software tools and commands available, and then have some practice with them. And that way, when push comes to shove and we have a problem on the network, not only will we be aware of the tool that we should use, but hopefully we've also had some practice with it so we can be that much more effective in troubleshooting and working with our networks. So in the next video, we'll narrow our focus just a little bit and take a closer look at some of these software tools that can be very helpful on our networks. So I'll see you, my friend, in the very next video. Hey, thanks for watching, and subscribe right here to get the latest information from CBT Nuggets. And if you're new to or considering a career in the world of IT, head on over to CBT Nuggets and sign up for a free trial.